Hi, my name is Xiaoxiao Lu. This is the final project presentation of wireless communication. My final project is linear adaptive equalizer using LMS and RLS algorithm. Here is the introduction. In modern wireless communication, there are many challenges need to be solved to make sure a highly stable and fast communication system. One of them is to avoid inter-symbol interference, which is short of ISI. Digital signal is reflected by the multiple path propagation. Inter-symbol interference will occur as the receiver. ISI will increase the data error rate of the system. The system cannot work properly in some worse condition. It has been proved adding a filter at the receiver can adjust and recover the damage due to ISI. This kind of filter is called equalizer. The duty of equalizer is to decrease bit error rate as low as possible, at the same time increase signal-to-noise ratio as high as possible. Adaptive equalizer is very necessary component of the receiver system to maintain the high quality of extracted signal. Using proper equalization algorithm, data error can be minimized due to multipath signal effects. In this paper, three types of linear adaptive equalizer will be developed and implemented with MATLAB. Three adaptive equalizers are using least mean square algorithm, recursive least square algorithm, and constant modulus algorithms. All the three linear adaptive equalizers are designed and simulated successfully. At the end of the paper, we analyze and compare the simulated results from these different adaptive equalizers. First, let's talk about the least mean square algorithm. Least mean square algorithm is a desired filter which has the proper filter coefficients. With the coefficients, the filter can produce the least mean squares of the error signal. It is more stable than ZF adaptive equalizer. ZF is zero forcing. LMS algorithm is popular in many applications because of its effective performance and simple design structure. LMS filter use small step size statistical theory, which provides accurate description of the transient behavior. The iterative process of LMS concludes computing the output of a FIR filter produced by a set of filter coefficients, which is connected to the generation of an estimate error by comparing the real output and the desired output, and then adjust the filter coefficients according to the estimated error. Next, let's talk about the recursive least square algorithm. RLS algorithm finds the filter coefficients recursively, which minimize a weighted linear least square cost function due to input signal data. Comparing to LMS, the input signal is considered as a deterministic, while in LMS, the input signal is stochastic, so RLS has faster convergence than LMS, but it costs more complexity. There are three operations of RLS algorithm performance. One is to calculate output signal of adaptive filter Yn. Two is to calculate error signal En. Three is update the filter coefficients. Last we talk about is the constant modulus algorithm. Blind adaptive equalizer plays an important role in band-limited digital communication system. The original equalization algorithm needs training sequences. Transferring the training sequences will occupy the frequency spectrum, which is very valuable. Blind equalization does not need the training sequences. It only uses the prior information of transmitted signals to equalize the channel characteristics. So blind equalization will increase the channel's efficiency and get the probability of equalization at the same time. The constant modulus signal is one kind of the most important communication signals, and probably the constant modulus algorithm is the most popular blind equalization algorithm because of simplicity. Here is the simulation result. First, let's talk about the LMS algorithm simulation result. The sending signal is a common sound wave signal, and after go through the communication transmitting channel, the receiving signal with a lot of noise, and after going through the adaptive equalizer, the output signal recovered very well, and the error signal, the convergence rate of the error signal is showing in the lowest part of the result. Next, let's talk about the RLS simulation result. The sending signal is the same as the RMS, and the receiving signal is in the second part. The output after going through the adaptive equalizer is the third part of the result, and the convergence speed of our signal is showing at the end of the part. Last is CMA simulation result. The input is the modulation for QAM signal. First picture is the original input signal, and the second picture with the green color is the output signal before the CMA adaptive equalizer, and the third result picture showing in the red color is the output signal after the CMA adaptive equalizer, and the last picture is the convergence speed of CMA adaptive equalizer. And here is the conclusion. The project discusses the theory and application of linear adaptive equalization. Three different classical algorithms about equalization are implemented using MATLAB. From the simulation result, three algorithms can achieve pretty good performance as adaptive equalizer. RLS has better convergence rate than LMS and better equalization performance, while RLS has high complexity and LMS is much simpler than RLS. CMA does not need to occupy the frequency spectrum, so it has good performance efficiency. That's all. Thank you. And now let's simulate using the MATLAB to see the whole simulation progress. First, let's open the software. There are three projects we need to simulate. First is the LMS algorithm with adaptive equalizer. Run the program. Here is the simulation result we talked about in the presentation. Second, we simulate the RLS algorithm. Here is the simulation result. last is the CMA adaptive equalizer. Here are the simulation results. This picture is the input signal, which is ideal for QAM modulation signal. And this one is the green one is the output signal before the adaptive equalizer. And these two are the output after going through the adaptive equalizer and with different ISNR. ISNR is signal to noise ratio. And that picture is the convergence rate of the CLA adaptive equalizer. Okay, that's all. Thank you. Thanks for watching.